So now in this video we're going to take a quick look at a voltage doubler circuit. So this is not a good one. There's more we have to add to it, but this will cover the basics of what a voltage doubler does. So right now you can see we have a steady voltage to the LED. It's 5 volts, but I have the current set up quite a bit of the power supply to make sure it's not a current setting here that starts limiting voltage because we exceeded too much current, because we're going to instantly charge a capacitor. So, when it comes to voltage doublers that use a charge pump, so it charges this capacitor, and then that capacitor voltage pumps into the load, in addition to the power supply voltage. That's how you actually up the voltage. We'll look at that a little bit later. But in any case, we suddenly charge the capacitor, we could lose a little current. So, we're looking at the voltage right now at this point right here. So we saw we have a 5 volt power supply. 1, 2, 3, 4, 5. We're a little short that because we have a rectifier diode. That's important to this circuit, is rectifier diodes. And so we have the black alligator clip from that cable to this jumper to the negative rail. In relationship to that, we have the red jumper where we get our 4.3 volts right there. If I go to the positive rail, you can see it shoots up to 5 volts. But we got the drop of the LED. So let's look at what the capacitor is doing right now. The capacitor is also at the positive rail, so it's discharged. We got positive on both sides. If I move the jumper to the negative rail, first off you see a dip there, and you saw the LED kind of briefly pretty much turn off. And so we have to improve the circuit to avoid that. But the main point of this video is just to look at how we can create basically twice the voltage with a capacitor. And so we got that out of the way. We will remove the jumper, and there you can see the LED got brighter and the voltage went up. So this is 1 volt per division. We can change it to 2 for a more accurate view. So I just hit that button, and then you turn the dial counterclockwise, it goes down. Clockwise, well, the line goes down, but the voltage actually went up. So now it's 2, 4, and then about 0.3 volts right there. And we'll get it more accurate. So this is going to charge the capacitor, and you saw the dip there. One way to maybe avoid the dip, so this is a 470 microfarad capacitor, as is this one. 470 microfarad. That's a 1000 ohm resistor, 1 kilo ohm. So I'm going to put the positive side to the positive rail, negative side to the negative rail. That might smooth out that dip a bit, because it can provide current while that one's charging. It's because the power supply kind of has a lot of stuff in between it. Maybe the resistance along the way is kind of limiting how fast current can suddenly change. So we had that voltage doubling though. We'll get rid of this to simplify what's on the board. So here you can see the capacitor. Most of the time it's not doing anything, as long as we keep it to one rail or the other. You can see we have a current path through the rectifier diode. Cathode's over there, 1000 ohm resistor, and the LED cathode is over here towards the more negative side. So the anode of these two are towards the positive side. So we have a current path going there. The capacitor, when we have this to the negative rail, is in series. So it took some of that current briefly and charged the capacitor. And then once the capacitor charge is not doing anything anymore, current resumes going smoothly through the 3 other series components there. The rectifier diode, resistor, and the LED. When we put this back to positive now, the capacitor was charged. That side was more positive. That side of the power supply is more positive. So if you put positive to negative, and then have positive head over towards negative of the other power supply, that's putting them in series. So we got the 5 volts of the rail, and then when the capacitor is charged, and we add the capacitor in the equation, that's adding basically 4.3 volts, but we're going to say 5 volts to keep it simple, in parallel, as long as the capacitor is charged. So the larger the value of the capacitor, the better this circuit would work. So now it's charged, and it's separate from this other circuit, other than it can steal some current rapidly, so the LED drooped, and now it's in series with the power supply coming to the load, and so their voltages add up. That's how the doubler works. And what the diode here does, it allows this side of the capacitor to be connected almost directly to the positive rail, but when we connect this side to the positive rail, it doesn't discharge positive rail to positive rail. It doesn't discharge there because of the direction the capacitor is. Current can flow that way, but not that way. And so it's got to flow that way. We're talking about conventional current, positive to negative. So that's all we're doing. There we go. We charge the capacitor. We can even yank the diode now, and we go there, and we had that increase of voltage. So you won't want to do that in a practical circuit, but for demonstration, you can see this diode only lets the capacitor charge, and in this case allow current to keep going through the load when we're not doubling it. So you can imagine if we did this fast enough, there's a brief period where it drops, but even in this case the voltage is higher, much longer than those brief little dips that we got. So we'd have more voltage to work with if we did this fast enough and we had a capacitor to capture it and whatnot. And that's what the additional circuitry is. You have another capacitor that captures it, and you prevent it from losing that voltage. We'll look at that in upcoming videos. But for this one, I just wanted to introduce the basic principle of how a capacitor being charged and discharged, going in series with the power supply, can provide almost twice the voltage of the power supply to a load. So I hope you enjoyed the video. Make sure you check out one of the other ones that I'm posting, and click subscribe, the bell, like, and whatnot, so that you see more of my videos. I will see you in the next video.